So the question that we chose for you guys today is the one that you see right here, which is it says find a function whose tangent has a slope of 1 over square root x squared plus 2x minus 3 for each value of x and whose graph does not touch the y-axis. Okay, there are some keywords that you guys should look at in this question, which is one is the slope and tangent, which tells us that it's a derivative of a function. So the derivative of the function would be 1 over x squared plus 2x minus 3. So basically dy over dx equals to 1 over square root x squared plus 2x minus 3. So in order for us to get the equation of the graph, we will have to integrate dy dx, because the opposite of differentiation is integration. So right now I've written down the function of the previous question that you just saw, and in order for us to get the equation of the line, we will have to integrate this function, which is x plus 1 square minus 4. Okay, there are two ways for us to integrate this. One is by using the integration formula or the integration table, and the other way is a more detailed method, which we will be using integration by part. Okay, so I will be explaining both of the methods. Okay, the one that you see right now is by using the integration formula. So I'm gonna let u equals to x plus 1, and when we differentiate that, we will get 1, which is du equals to dx. So by solving that, we get square root u square minus 4. Okay, integrating this, we will get ln u plus square root u square minus 4 plus c modulus, and the next one would be x plus 1 plus square root. We will substitute back our u equals x plus 1 into the equation, which would look like that. Okay, so our final equation for fx is ln x plus 1 plus square root x squared plus 2x minus 3 plus c by expanding that. Okay, now I'll be showing you the more detailed method of solving the integration dy over dx 1 over square root x plus 1 square minus 4. Okay, I'll be explaining about the long method, which we should be able to get the same answer, which was this. Okay, so right now when we're going to integrate 1 over square root x squared plus 2x minus 3, basically like that, we're gonna let x plus 1 equals to u and du over dx equals to 1. This is integration by substitution. Okay, so we would get this, and then we're gonna do let u equals to 2 sec theta, and when we differentiate du over d theta, we will get 2 sec theta times theta, and we bring d theta over to the right. Okay, by substituting u equals to 2 sec theta and du equals to 2 sec theta tangent theta d theta, you will get this. Okay, right now to integrate this, we're gonna simplify it first, which sec square theta minus 1 is basically the trigonometric identity of tangent theta, as you can see right here. And the next step would be square root, and we would simplify for tangent square theta to tangent theta, and by cancelling off tangent theta and 2, we are left with secant theta. And simple integration of a trigonometric secant theta, we would get ln secant theta plus tangent theta plus c. Do remember the plus c. Okay, now we're gonna, in order for us to solve this, we're gonna replace theta in terms of u. So we're just gonna let secant theta equals to u over 2 and secant square theta is u over 2 square. So according to trigonometric identities, secant theta equals to tangent theta plus 1 equals to u square from here. So you see, and then we're just gonna solve that to finally get tangent theta equals to u square minus 4 over 2, which we would substitute into this one right here, the first equation. Alright, and we would get ln u over 2 plus square root u square minus 4 over 2 plus c1. And when we bring it down and solve it, we would finally get ln u plus square root u square minus 4 plus c2. However, u is not the final answer that we're looking for. So we have to substitute u, which is x plus 1, and we would get the final answer in terms of ln x plus 1 square root x square plus 2x minus 3 plus c. And as we can see, both of the equations are the same. But referring back to the question, it states that the graph does not touch the y-axis, which means the y-intercept equals to 0. So looking back at the equation that we got, our final equation should be x plus 1 square root x square plus 2x minus 3, and that would be it as c is 0.
Hello, okay, just now we have explained about two methods of integrating functions, which was first by parts and also by substitution method. Now I'm going to show how to apply one of the methods to find a volume generator. Okay, so as you can see, this is the question. The graph function fx equals to x over x minus 3 forms a three-dimensional shape when rotated at y equals to 0. Find the value of the volume generated. The range given is 4 is more x is more than 4, more or equal to 4, and is less than 6, and also equal to 6. Okay, so without further ado, let's get to the working method. Okay, let's write down the function, which is y equals to x over x minus 3. Okay, before we get into the calculation, let's draw the graph in the first place because we want to get a clearer picture. Okay, as you can see, this is a irrational function. So first of all, we need to find the horizontal asymptote. So to find the horizontal asymptote, we need to take the denominator of the fraction, which is x minus 3, make it equal to 0. This way we can find, we can see that x is not supposed to equal to 3, because if it is, then we would get an undefined value. So x equals to 3 is somewhere over here. Let's just assume the 3 is here. So this would be our vertical, I'm sorry, it's supposed to be vertical asymptote. And now we need to find the horizontal asymptote. So to find the horizontal asymptote, we just need to take the unknown, the power of the unknown here is the same, which is 1 and 1. So to get the value of the horizontal asymptote, we just need to divide x over x, and it would give us 1. So basically the horizontal asymptote here is 1. Okay, so 1, and this is our horizontal asymptote. Okay, so the graph is gonna be like this basically, and since the value of our x is positive, the graph would look something like this. Okay, so now we've gotten the shape of the graph, and now let's get into the calculation. So to find the volume of the graph, which is from 4 to 6, so the shape is gonna be like this. Okay, so when this area is rotated along this axis, y equals to 0, we would get something like this, the shape. Okay, so now we've gotten the picture, so let's get into the calculation. So to find the volume, all we need to do is to integrate x over x minus 3 square part dx. Okay, so to do this, we need to expand this, so it will become x square and x minus 3 square. So in this, okay, so this pi we can factorize it and write it right next to the function, because we're gonna have to multiply this with the value that we'll get once we input all the values. Okay, so in this case we're going to use the substitution method as explained by Vinod just now. Okay, so we're just going to let x minus 3 equal to u. Okay, and then this would become u square, and when we integrate this function here, we will get dx is equal to du. Okay, so we can substitute this dx equals to du into our dx here, and it will give us du. Okay, so what are we going to do with x squared? Okay, so we have already assumed that x minus 3 is equal to u. So all we have to do is we have to express this x in terms of u. So it will give us x equals to u plus 3. Okay, just substitute that into our x. So it would become something like this. Okay, so now we have gotten a single denominator. So now we need to expand this expression u plus 3 u square. So when we expand this, we will get u square plus 6 u plus 9 over u square. Okay, so as you can see, the denominator is u square, which is a single number, and as you can see, the numerator is composed of many numbers, u square plus 6u plus 9. So what we can do is we can expand this fraction and write it, that is 6u over u square, and also plus 9 over u square. Okay, at this point, what we can do is we can integrate every single term separately. Du plus 6u over u square, 9 over u square. Okay, so when we integrate u square over u square is basically 1. So when we integrate 1, we will get u. So just gonna put, so 6u over u square is 6 over u du plus 9 over u square du. Okay, so now we can start integrating every single term. So when we do so, we get 1. If we integrate 1, we get u plus 6u. Okay, 6 is the constant number here, so we can take this out, and we will get 1 over u. So integrating 1 over u would give us ln u, and also 9 over u square. You have to bring to the top, it will become 9u to the power of -2. So integrating that would give us negative 9 over u. Okay, forward the equal. Okay, so now that we've gotten the integrated terms, all we have to do is substitute the initial equation. Remember, x minus 3 equals to 0. Just substitute the whole thing into the u here. So we will get pi in bracket x minus 3 plus 6 ln modulus x minus 3 minus 9 over x minus 3. Okay, so now we can input our limits, which are 4. Okay, so substituting 6 into the equation would give us would give us 6.59 minus, and now we're going to substitute 4 into the equation, and that would give us negative 8. So overall you would get a value of 14.59 unit cube. And there you go, and this is the final answer for the question.